All right, if you recall, yesterday we were graphing one inequality at a time, and then everything in our shaded region was our solution. Today we're going to take that a step further and solve systems. So we'll just do two at a time, but technically you could have more than two as well, which will make our set of solutions a little bit smaller than it was before, but you'd still have multiple solutions. So instead of just graphing one line and shading, we're going to graph two, and then where their shading overlaps is really our solution. So that's what we're working on today. So let's go ahead and move on to some examples. So these two questions will be easier for me to answer after I have a picture to work from. So we're going to do that first. We're going to go ahead and, so you could also do it algebraically. You could plug these in. You could plug in 1 here and 2 here and here as well to figure that out. So like if I plug in 1 here, I'd have 1 is greater than 1/2 times 2 is 1. That would be true. I could also plug in here 1 is greater than -2 plus 3. 1 is greater than 1. That's actually not true because it doesn't have the or equal to. So I would know that's not a solution. But sometimes, especially with these inequalities, it's a lot easier to work from a picture. So that's what we're going to do. We're going to make our picture next. So here I have y, so actually, I'm sorry, I'm jumping around. Is 2, 1 a solution to the system? We already know it's no, but I'm going to show you why it's no down here. So y is greater than or equal to 1/2 x. If I graph this line, I would start in the center and go up 1 over 2. Then I would need a solid line because it's or equal to, and I would shade above because it's a greater than. So solid line here, and then I would shade above. Okay, so there's one line. So now let's graph the other on the same graph. We have -1x plus 3, so we'd start at 3 and go down 1 over 1. And this one needs to be a dashed line because there's no or equal to. Let me adjust that. There we go. And then this one's greater than, so we're also going to shade above again. Okay, and then our solution is now just what's in the green section, okay, where they would overlap. So our solutions are not in the yellow or the blue or the white, only in the green section. And they can be on this line, but they cannot be on our dashed line. So if I scroll back up here, 2, 1 would be right here, and because it's on this dashed line, that's why we can't include it. And then 3, 6, if I count over 3 and up 6, it would be in my green shaded region, so we would say yes. So in 3, 6, you could also plug in. So if you prefer algebraically, you can still do that when it's just asking if it's a solution. If it were to ask you to show all solutions, you do need a picture for that because there's no possible way we could list them all. All right, next example, y is greater than or equal to -x plus 2. So we can go ahead and graph that one. We can start at 2 and then down 1 over 1 for our slope. This would be a solid line this time, since it has that or equal to. And we would shade above, it looks like. Okay, so something like that. Then for this one, you can graph using intercepts, or you could rearrange it to be slope-intercept form. I'm going to go ahead and do intercepts. So when x is 0, y would be 1. When y is 0, x would be 2. So 0, 1, and 2, 0. And this line would be dashed. Let's go here because it's a less than. Little lower here. That looks better. This line would be dashed because it's a less than, and we would shade below. Now, the only thing I would caution you if you're going to graph using standard form is that sometimes this sign might flip if you had a negative coefficient in front of y. So sometimes it would be smarter to isolate y just to make sure. This one is not going to flip because there's no negatives on the left-hand side. Just something to keep in mind. So we're shading below. And then our solutions are in the green section, remember. So if I were to pick a solution, like it's going to ask you to do on Delta Math, I could pick anything in this green section. It'll take every single one. Okay, I can also pick something on this solid line, but I cannot pick something on the dashed line or where they cross right here. So it's safer to just pick something in the green section. But let's say I had like 3, -2, that would be a solution. Okay. So everything in the green section works. You just have to pick one for your assignment today. And then one more example. Y is greater than -x. That would be starting at the origin and then down one, right one. And it looks like that would be a dashed line. Shading above. Okay. And then this would also be a dashed line shading above. So let's go ahead and draw that one in. This one would start at 3 and down one, right one. Right here. Yep. And shade above. Okay, so where these overlap would just be this green section, but it also happens to be just the second line. This first one doesn't make a huge difference. So that'll happen sometimes when they're parallel. If they are parallel, but they're shading in opposite directions, like let's say this middle part was left clear and you had yellow here and blue here, that would be an instance where you'd have no solutions because there's no overlapping. So that's something to look out for as well. And this one isn't quite infinitely many solutions, but it is the same as if we only had this line. So the picture is still our answer. The green section is our answer, but it's also the same as if we had gotten this line, rid of this line altogether, which doesn't happen a lot, but does happen sometimes when you have parallel lines. As if they aren't parallel, you're always going to have a solution because they're always going to overlap in some manner. But when you have parallel, you want to be on the lookout. Sometimes you have no solutions when they don't overlap at all, and you have no shading in the center. All right, you are working on a Delta Math assignment today, so you can go ahead and move on to that.